Hello, this is Billy from Billy C DIY. If you've been watching my videos, you know that I have created this type of credit card sized game machines with a pedal so you can play this type of old games with your kids. And I also designed a PCB so I can build it out like a better product. After soldering, this is what I get. The Arduboy clone, which has 400 plus games, and you can play a lot of different type of games like this one using your pedal. And in this video, I'll show you how to make it, from designing the circuit to creating the PCB design to how to order it and fabricate it. Thanks for watching. If you like my video, please click like, subscribe, share with your friends, click the bell, and leave me some comments or questions. I'll answer it ASAP. Thank you. Today I want to show you how you can design and create a circuit and a PCB for any electronic products, including the Arduboy clone 8-bit retro game machine that I have shown in my videos. So first, we need to search for this product called ECEDA. It is a software service provided by a electronic company in China. It's free to use. It has the online PCB design and other things. So we'll be mainly using the ECEDA editor. So click this link. Okay, if the first time you use this product, you just need to register with a username, email address, password, and then it will send you some confirmation code to your mailbox. Then you can just continue to type the verification code and then you'll be all set. Okay, since I already finished signing up, so I just log in with my username. Okay, once you have logged in, you can choose to design online or you can download their software. And you have options to store your design files either online or in your PC or Mac. So I won't go through that. It's straightforward. You just download the software and install. For the sake of this demonstration, I'll choose design online, and I will use the standard version. Yeah. So next, we need to open this sample design file that I have created for my Arduboy clone retro game machine. There are two versions. One is the full-size version. The other one is a minimized half credit card sized version. So let me go through the full version first. This is the link. You can find it in the YouTube description. Okay, ECEDA has another website that they run called OSHW Lab, where you can post any open source hardware design for sharing, including your design drawing, the circuit diagram, and the PCB that you designed. So once you share it, it will be in the public domain, right? You can choose your licensing to determine how people use your open source file, whether it can be used to create commercial product or is limited to home use. So this is described in different type of licensing. And you have a description. For example, this one is a game machine capable of holding 500 plus games. Then this is the schematic circuit diagram and the PCB. Okay, so let me show you the other one that we'll be using. Let me open this other one. So this one is similar to this game machine, but a different version, a baby version. Okay, so this is the baby version, smallest version. The design is a little bit the same, only that the pedal, I've reduced the pedal to just one, so you won't be able to play the two-user games on the pedal. This is the PCB. Okay. Let me now show you how you can create your own design based on this one. Okay, so let me go back to the full-size version. Okay, you can open this open source file in the web-based ECEDA editor by clicking this button, Open in Editor. Okay, there's some web browser error. You can ignore that. Okay. So this is the design circuit diagram, and then you can open up the PCB. You can see the PCB diagram. You can choose to view different part of the PCB. Like I only view the top layer, and you only see the trails on the top, or you can view the bottom layer. So you can see the trails at the bottom. And then you can also choose to see them all. To see a 2D version, you can click this one. This will give you a 2D version. Okay. You can flip the top side and the bottom side by clicking this button. You can also view the 3D version. You can view the 3D version here, clicking this 3D button. Okay, then you can move it, rotate it, to look at the trails in detail, zoom in, to see if the contacts are too close together, and then you can fix it. And you can check out all the silk layer, that means the printing on the circuit board, whether there's any misspelling or it is painting on top of the soldering pads, which is not desirable, because otherwise you can't solder with the paint on top. Okay. Sometimes if you got a 3D model for your component, it will appear here as well. So it's up to you whether you want to take the trouble to find all the 3D model and link it to your circuit board design. If you got it or it's already there, then it will also show up. Okay, then let's go to the circuit diagram. Let's click this button. So this is the circuit diagram. Again, you can zoom in or move it around to see it. Zoom in by moving the wheel of your mouse. If you press and hold the wheel of your mouse and move your mouse, you can move the circuit to area where you want to zoom in. Okay. There are already some nice video on the YouTube to show you how to do basic operation of ECEDA. You can go there to take a look. ECEDA tutorial. Some of them are created by the company who created ECEDA. So these are the basic tutorial how to do different things. You can go through those in your spare time. Right now I just show you a quick way how you can create a PCB based on this circuit diagram. Okay. So your circuit diagram needs to be complete. That means all the open connection need to be complete without missing connection. Any connection you don't need to use in your circuit, you need to mark it with this X. Okay, so this is an open connection. To fix it, you need to move the X, place the X here, move the X here, and connect, and click again. And now this open connection will be gone. So now, assuming you finish your circuit diagram, you can now create a new PCB. To convert this circuit into a PCB, you click this design and convert schematic to PCB. And now waiting for some parameters. First is the unit, we choose millimeter. Then is the number of layer of the PCB. Now we choose 2. Then the different shapes, rectangle, circular, or rounded rectangular, or the custom made. So which is some shape you design yourself. Let's choose round rectangular. Then let's worry about the width and the height first. The width, we measure the size of the credit card is 85 millimeter. The height around 55. And then the starting point is like the XY axis diagram. So the higher the number of X, it will go to the right, negative number go to the left. So for Y-axis, higher number goes to the top, negative number goes to the bottom. Okay. So let's choose some number so we can see the PCB very clearly. So let's put some margin like 5 millimeter margin to the X, and then let's put 60 millimeter for the Y, and then we can apply. Okay, so this is the PCB. So you can see there's already some components showing with all the connection lines below the PCB. Our next job is to place this component onto the PCB one by one. And then as you move it, the connection will not break. It will just continue to move. So first, let's place our display. Okay, the display, we want to place it at the top. Okay, you see all the white lines? The connection are now dragged over, but it will not break. Right? So let's place the display. When you click this, the component property will show on the right. You can see you can assign the component to the top layer or the bottom layer. Right now it's assigned to the top layer. So for the display, we want it to show, to be mounted on the front of the circuit board, the upper side, the top layer. If you choose the bottom layer, you'll find that all the description is now in reversed because it's mounted on the bottom. You are looking at it from the opposite side, like the other side of the mirror. So it's now reversed. You can flip it back to the top layer. Now it will become normal. Then let's place the other component on the top first. You can see as you move, you will see 2 red lines like a cross, so you can use them to do some alignment. Or you can use the automatic alignment feature. I want to align this to the same horizontal position. I will highlight the 2 and then use the format. You can align the left side of both components to the same X position. Okay, you see this one moved a little bit. Now we can align the horizontal position. highlighting both, and then click Format, Align Top. This right button moved up a little bit. So now let's go to the bottom layer. To allow you easily see the bottom layer, we can use this view icon here under the layers and object window to remove the top layer, to make it disappear for the time being. Okay, and then we only view the bottom layer, so we will edit the bottom layer. Then we also remove the top seal layer, so you don't see the drawings. Okay, and we only see the bottom layer. Now it's easier for us to move the stuff. Forget about the top layer first. Okay. The first thing we want to move on. Okay, it seems some of the component has been set to the top layer. So once we remove the top seal, they are gone. Okay, so now let's fix something first. Let's try to make everything here remaining to be the bottom layer. Okay. So you can see there's an objects property. When you circle and highlight all the components as a group, you can change any parameters of that all the objects within the group, like which layer they go to, right? So let's change them all to the bottom layer. Okay, now it's all changed. So now if you remove the top layer and the top seal layer, those components will still be shown because they have now been flipped to the bottom layer. Now we can easily move them into the circuit. And now let's move the let's place the Arduino micro circuit board first. So we move it to the middle of the bottom layer, and then we can rotate it. How you rotate it is by format, rotate right or left. Okay, so we need to rotate a second time. You flip it 180 degrees. Or we want to place the USB connector at the edge of the circuit board, but leaving some space so it won't be scratching the edge. Okay, so let's see. This is fine. So we can easily charge the microcontroller by plugging in a USB-C cable. Okay, that's why the USB connector needs to be placed at the edge of the PCB at the bottom. Then we can move the other component. Then the last thing to do is to route all the trails to the best position so they don't overlap or cross short circuit. Okay, so how to do that? First, of course, you have to save your PCB. Okay, just click File Save to save the PCB. Then you can do the first check your design whether there's anything wrong, right? So there are some design rules. What is the clearance? What's the width of your track? Drill diameter after that, right? So you have to put in this parameter first and apply the setting before you do the debug. Then you can run the check DRC under design menu, check DRC to run a test to check whether there are any bugs in your circuit design, right? So for example, all these red marks with a cross, that means you've got a problem. Some of these are too close together, so that's why you got this red mark. So let's click on it to see what's wrong, right? So when you click on this, it will zoom onto this one. Okay, you can see this one is too close to the pin header, the 2-pin header. Okay, so we have to move the pin header up a bit or down. Okay, so it won't overlap. Okay, next one. It's a similar case. Let's reroute again. No, let's do the auto route again. Okay, you see, it's important to see whether there's a fail. Fail is 0, and then the system has rerun the auto reroute 103rd time until it finds a possible way. And then the total vias means if you need to connect a connection from the bottom to the top, you need a vias, right? Like a hole being drilled and then a wire being placed, a track being placed to connect the top layer and the bottom layer. So those are vias. You want to reduce the number of vias to the minimum. The more vias, the easier your circuit board will fail or will be damaged. When someone press the via or damage it, then or there's a change in temperature, those via may not connect again. So you want to reduce the number of vias. Okay, so this seems great. Okay, so now I think we need to rerun the check DRC. We forgot to do it. So you see, after rerun, there's no error, 0 error, right? Now we do the auto route and run. Okay, that's nice. So to check the output of the PCB, you can click the 2D button to see the 2D layout of your PCB. Notice whether there are any bugs in terms of the silk printed layer getting out of the range. Like this one, the reset is a little bit off the board. You can also flip to the bottom side by clicking this button. Okay, you can notice whether there anything you need to improve, right? Like this one also goes off the board. The other thing you may notice is the resistors, the values are not shown, so it may be a little bit hard for the makers to place the right resistor on the circuit. So how do you fix it? So let's go back to the PCB. Okay, if you want to move the wording, right, the seal printout, you have to change the edit to edit seal layer, like this one. Click this box, the yellow box, so you can edit the seal layer. Then you click on the things you want to move, like this pedal should be here, reset should be here. If you don't want to print the whole thing, just change it like that. Double click and override the text. Okay, now we can go to the bottom layer, bottom seal layer. Let's edit the bottom seal layer. Let's remove the top seal layer so we can focus on that. For example, this one, this lipo, you want to rotate it, then you can just double click, format, rotate. Yeah, now it rotate. And then you need to rotate again. Okay, so the positive sign is on the square pin, negative is on the round pin. Speaker is the same. For the resistor, you can change it to resistor value. For example, this one is 2.2K, for example. This one is 4.7K, for example. Right. Additionally, you can also put your own brand name logo on top. So if we go back to the top layer, or the top seal layer, if you want to print your name there, let's click on this T text and drag it to the right place, and then you can double click to edit. Change it to something like this. One thing we won't forget is to add the drill holes to mount the circuit board. So we want to use this tool, the drill hole tool. Click on it and then move the drill hole to here. Now let's look at the drill hole. What is the size of the drill hole you want to use? 3 mm roughly. Or you want to make it a little bit looser, 3.1, so you won't get some issue with the boards. So once you finish it, you can copy it to the other corners. Paste, and you can edit paste again, edit paste again. And you need to align these screw holes, right? So you can click this one and use the command key to click this one. And you can use the align left, and this two also. Align right. And then you need to align the horizontal. I mean the vertical. You need to align vertically. Align bottom. Also be aligned top. Okay. These two. Bottom. To maybe move a little bit higher. Then align again. Okay, let's take a look. Auto route. Okay, let's take a look at the 2D. See the screw holes here. Let's take a look at the 3D. Okay. Okay, good. You can then generate the different output. So you can use the export, file export, to create a PDF. Oh, you have to save it first. Let's save it. And then you can file export. You can create a PDF. Let's take a look. So the PDF is like that. It's a combination of the top layer and the bottom layer. Okay. Or you can export the picture file. So depending on what you want to pull in, you can click this box. Okay. So it's the same type of thing, but it's a PNG. You notice that as I enlarge it, the quality will be dropped. You see the pixels coming in. See, the more I enlarge it, the more pixel. That's the problem with the PNG. Or you can export the SVG, the vector typographic. Good thing about this one is if you enlarge it, it won't change. Let me view it in the. Okay. So the best thing to do is to export to click this generate PCB fabrication file called Gerber. This is the industrial standard format for creating PCB. It will include all the information about the PCB itself, the size of the components, the seal layer, and everything. So before that, they want you to run the design check, right? So we have run it. So let's run it again. Design check DRC. And then let's open this box and see whether there are any error. 0 error, so we are fine. Then we can generate the PCB. Click no, just generate. And then it will generate this PCB. Size is 55mm times 85mm. Number of PCB, it will. If you want to place order with JLC PCB, you will need to input this information. Otherwise, you just generate the Gerber file. Okay, so Gerber file has been generated. Let's take a look. So this is the Gerber file. Let's go in. So it got this number of files. Okay, so what you need to do is there's a zip file. You just need to send this zip file to your PCB factory, the shop that will help you fabricate this PCB. Let's send them the zip file, and then they will be able to create the PCB that you need, like what I did with my PCBs. Okay, otherwise you can use the use this screen to submit the order to JCL PCB, that company who created software. They can also help you build the PCB. Depending on where you are, the shipping cost is different. They can also help you to order the surface-mounted device. They help you to order the equipment, the components and then help you put some of the SMD and components, solder them onto your PCB and ship it to you. So it's up to you, but those will be more expensive. Let me share some of the ways I did it in Hong Kong. Obviously I didn't use JCL PCB because that is for US. I ordered it from Taobao, the Chinese online shopping site. The price is not expensive and I got it in a week's time. So after waiting for a week, I got this circuit board printed with all the labels that I want, and I spent a whole day to solder the components, and 3D printed the cover using the drill holes. I mounted the screws to secure the cover to the circuit board. Now I can play this game. Pac-Man. Okay, this is Billy. I'm Billy C DIY channel. Hope you like my video sharing how to make a PCB. If you like my video, please click like, subscribe, share with your friends. Don't forget to click the bell so I can inform you when the next video is out. Leave me some comments or questions. I will try to answer it ASAP. Thank you.